the Scanner Shootout. Chris Kircheball is going to be starting us off. He's our laser scanning subcommittee chair. And Joe Nicoli is also going to be presenting. Give it up for Chris.
Thank you. Huge thank you to Andy Holleroyd and HTS for letting us use the facility in order to come to the conclusions that we have. None of this would be possible without him. So unfortunately, he's not here, but as alluded to in the previous session on laser scanning spec sheets, what do those numbers actually mean? So we did a laser scanner shootout where we had different models in same positions with materials boards, different angles, different activity values. And essentially what we're going to do is break down the analysis of the data, show you what we had in terms of positions and materials. And Joe's going to, kind of take you through what that process looked like and what the results were. So, Joe, you want me to jump up?
Oh, yeah.
Oh, okay. All right, so yeah, this is kind of going to rehash a little bit of this, but determining which scanner that you need. So how do you compare all of these scanners? Right, there's quite a few on there. What results can you expect? Is the data going to meet your need for your project? And what information can you trust? Sticking with the theme of apples, they're not all the same, right? So everything's in the medium range, but that doesn't mean that every product is the same. Okay.
So what we want to do today, we're going to try this out. It's something called Poll Everywhere, and we want to get your guys' engagement on this and see. Hopefully this works. If not, we'll just do a show of hands. All right, so let's just do this because we can poll anywhere. Would you find a uniform scanner spec sheet valuable? So a lot of hands went up on that. That's really good news for Chris here because he did a really good presentation on that before. All right, just real quick, what would you guys like to see on a scanner spec sheet comparison?
Maybe uniform analysis of whatever accuracy is or precision.
Okay.
Getting that into like one apples to apples comparison across.
Great. Yeah, we have, what we're trying to do with the spec sheet is normalize those comparisons so you can just, see apples to apples. Anything else? Yeah.
Productivity. Some scanners, end-to-end workflow, the specs look great, but when you get into end-to-end workflow and you're doing 50 scans, that could be a 2-day job, but that could be an hour-long job, depending on the scanner type and the software workflow and localization, all that stuff. So the spec sheet's interesting, but I look at it from the angle of how productive are we to get to some standard.
Yeah, no, that's a great point. I think Josh brought that up too earlier in a discussion we were having before the session is, that workflow, beginning to end really has an impact on the time, right? So is there a way to compare that scanner to scanner using that same workflow and what are the results? Does one save you more time or not, right? Is that what you're saying?
Essentially, the accuracy is obviously got to be calculated.
Yeah.
But at the same time, if I'm chasing millimeters, the value starts to get out of balance, and I'm looking at productivity. Can I get to the site quickly, need a standard, and get through the software workflow, get to the deliverable. And what I found is different scanners deliver. It's really hard to see just in the raw spec sheets that they give you what the productivity flow is. We do a lot of work for other companies that have scanners that sit in the closet because they fail kind of the productivity.
Yeah. Well, that's something we should like talk about in the committee, because I know it gets, I think once you get into workflow, you got a lot more variables. You're dealing with a lot of different software packages and, you know, so it gets a little outside of what we were thinking we can probably do with the scanner spec sheet, which is a piece of that. No, you know, compare your instruments, but then also compare how they work in a given workflow would be really good too, right? Anyone else?
Also on the same note, how do you measure productivity? Is it based on square footage or number of scans each day? You know, not every square foot is created.
Yeah, it gets complicated really quick. So we're going to try and boil a bucket, not the ocean, and try and at least get the spec sheet out before we take on something that's a heavier lift. So yeah, there's like basically two current projects going on in our scanning subcommittee right now. One is the scanner spec sheet, which we just had a whole session on, and you know, here's what we're dealing with right now today is how do you compare all this, right? And then this is an older version of what Chris had up there earlier, but same kind of concept. How do we take and get the information from these into a uniform format, like Chris's example of the Monroney sticker you see on car windows when you go to buy a car. So all apples can look alike, we think. If we can get them in, normalize them somehow, that would be the goal of the spec sheet. The other project is the one that these guys are going to present here right now, which is the laser scanner shootout, where we took various number of different lasers, scanners, and put them on a tripod in a shop environment, and we had material boards, and we basically set the boards up at different angles, swapped the heads, and gathered data, all from the same position. So that's our second project. And since this doesn't work, we'll do this quickly. Do you trust the accuracy claims stated by the scanner manufacturers? I got a bunch of thumbs down and maybe another, a lot of thumbs down. Oh, geez. None of our sponsors are in here. Anyone else have any thoughts on that? Okay, I'm going to keep going.
What do you think, man?
Let's just move on, everyone. When you decide which scanner to use, what do you typically do? Do you use the same scanner for every job? Do you choose a scanner based on what you feel is best for the job? Do you choose the lowest cost option? Or do you flip a coin or something else? B?
Somewhere between B and C, I think.
That sounds like a consensus. No one's flipping a coin. That's good news. Okay, B and C. All right, yeah. I'll invite Chris back up, and you want to finish? Or you want to take it, Joe?
Yeah, sure.
Okay, Joe, I'll let you take it.
Chris will answer all of the questions. That's the way we'll do that. So, okay, I think the general. Okay, so the scope: to obtain the comparison data on a variety of common materials, utilizing a range of scanners. So we have 4 boards. Scan the boards in typical settings in the field. Maintain the control of the scanner position. That's the key. So, okay, here are our 4 boards. So the first one is what we used to kind of lay it out. So it was a series of targets on a board. And then we have one that's kind of floors and laminates, ceilings, wall tiles, and then the last one is pipe and conduit. And there you can see Andy's lab, where we set up the boards at various locations and various distances. I could tell you, because I don't know if this comes up later, what we've processed so far is all from position B. So that's the one kind of straight away at 23 feet offset. So that's the one we're going to be talking about. I think there is some utility to, you know, the short angle shot and the shot above. I think there's, you know, I think they did a good job of kind of aligning the boards to, you know, the various positions you would find on a job. So, but for our purposes, we'll mostly be talking about position B today. And again, this is how we kind of established the locations for all of these things. So he's got little markers set up around his shop, and then he's got a central point that he surveys from in there. Okay, so go through the scanners that we used here real quick, and then we'll start talking about it. So 4 different Faro scanners. He did it at a quarter and a fifth, and I'll talk about the differences there here in a sec. ZNF, we had a 5000 6i and a 5010X. We did a middle and high. High and 3 different Leicas, RTC, C10, VLK. So these were all added this year, the Leica ones. Or no, we did the C10 in 2017. And then a Surphaser and a Trimble. Trimble was added this year. Yeah, the Trimble was added this year as well. I think I got that in. Okay, and we went back and forth a number of times over this, and this all plays in with everything that Chris talked about earlier in the session and how we're going to move forward with this and standardizing all of this kind of terminology. But for our purposes, the way that I moved this forward was to say that ultra high or super high or HD or whatever the manufacturers are going to call it is 2 millimeter spacing at 10 meters or better. High is 3 to 5 millimeters at 10 meter. Medium is 6 to 10, you know, or normal or regular or whatever the manufacturer wants to call it. What I'm calling it is medium at that resolution. So low is, you know, more in your half-inch range, and then extra low or fast or quick or whatever they call it is, you know, half an inch to an inch spacing. So the one caveat I will say here in that, in coming up with this, we did scan with the Faro at a 5th and a 4th, rather than a 4th and an 8th. So the 5th scans that are listed as lower up here are probably better classified as medium low. But they are 2 different settings on there, so I did include them so you can see the difference of them. Okay, the analysis. Yeah, I think maybe it's important to point out here, we're not trying to find the best scanner. This is just what we found when we went through and captured all of the same stuff in the same way. I'm not advocating for any of these. Every job needs a different tool.
Yeah, no, that's a good point, Joe. I think, you know, we're not trying to be a consumer report here and tell you which one to use. It's real important that we convey that. All we're trying to do is find a way to normalize the comparison between the data that comes out of these. And then, you know, our philosophy is, you know, they're all tools. They all have their strengths and weaknesses. We're just saying, okay, here's some common materials we all encounter when we're on jobs. You know, this is not a NIST-like, you know, laboratory analysis. You know, we don't operate in a lab environment in the real world. We have, you know, these are all the scanners we used are all, you know, currently calibrated. They came from Andy's inventory primarily. HTS is a scanner rental company, so we had access to a tremendous number of scanners, which was great. But these are all production scanners, and we all work with those every day. So we thought, you know, let's use a production scanner that's properly calibrated, and let's test it on real-world materials, and let's see what we get when we compare them. And then you guys decide, right? If you can compare these data sets. Hey, I think David over there said he was, you know, scanning some, you know, reflective surfaces. You know what scanner works particularly well with, you know, oil insulated ducts, you know, when I'm doing above ceiling. I get a lot of spray, you know. Well, maybe there's one of these scanners does a better job than the other. I don't know which one, but, you know, the data's there now, and we got so much data. We had to narrow it down to just, you know, the one, you know, the B board, you know. We could analyze this stuff, you know, in perpetuity, but we decided to focus on the B board and publish it and let you guys decide.
Okay, quick word on the methodology here. So I registered all this data in Polyworks. So the data came from the scanner software and was registered into Polyworks. And the way that I registered them all in Polyworks was just to eliminate the boards themselves as registration targets. So it's all cloud-to-cloud fit of the room itself. And then the individual boards were exported out as unordered point sets. So XYZ intensity into point tools. And then I took those into Rhino, because Rhino was the easiest way for me to replicate the same screenshot over and over again and cut sections at a repeatable position. So that was the method I used. I know we've talked about intensity here as well. And so I did mess with the brightness and contrast on the screen captures to try and give it visually a, comparable across the surface, because as any of you who've used more than one scanner know that the intensities don't really translate between the equipment. So the data that we produced is those values, the regular intensity values set from 0 to 255, but I did play with the brightness and contrast just to try and get it a little more comparable visually. So it's the 2017 boards, and you can see 320 boards in the 2017 setup, and that was the board that we actually talked about at the symposium. I think, did you talk about that?
Yeah, so that's what, that's board C, position B,
yep.
Correct?
So that was the ceiling board. So I don't think we have the actual,
We also
I think online we have it listed, what those materials are.
Yeah, we took the boards, we set them up in their original position, and then we also, in addition to taking a scan with each unit in that position, we also shifted the boards to different positions and took another scan. So you can see we got just a tremendous number of scans to evaluate with, 4 different boards in 4 different positions as a comparison.
At least 2 settings.
Yeah, at least 2 settings. So it's a crazy amount of data.
So, and this one, so we did go back and added in this position for the other scanners. This position and this board are now all up on the website. So that's a full set. Well, is this something? Are we going to talk about that later?
I don't know if it actually made it up yet or not, but if it's not up yet, it will be shortly.
We'll talk about that later. Here are the samples we added. So we added a high res and a medium res from Trimble, and then high, medium, and low for both the BLK and RTC. And now, again, we're going to talk about the B board here. So this is floor and counter finishes, position B. Okay, move this one up for a sec here so you can get a sense of what we're talking about. So we have linoleum tile and peel and stick vinyl tiles, a bunch of paint swatches down at the bottom, bamboo flooring, engineered flooring, and then quite a few laminates of different colors and kind of reflectivity values. Okay, then this is going to be the layout that all of them are presented in. So kind of cut right down through the engineered flooring, the bamboo flooring right through there to see the section, do some of the laminates and paint samples. And then we have 2 sections. So there's the kind of top to bottom section that's going to show you the whole slice, and it was a centimeter wide slice in point tools. So you get 1 or 2 lines. And then the close-up on the bamboo flooring and the couple of engineering floor. Or I'm sorry, the countertops samples. All right, so I guess we'll dive in. I have a ton of these. I don't know how we.
We'll just kind of walk through.
Just kind of walk through some of them there. You can kind of see what we're talking about. Does that make sense? What you're seeing there, the resolutions and sections and all that kind of stuff.
Really just more of a visual comparison, so you can, if you get, get these data sets and you want to start comparing them yourself, you can kind of toggle between them and see the differences in, you know, the section profiles are pretty telling, you know. And I don't think we had a shiny surface on this board for David, but we've got one somewhere, one of the boards.
Yeah, I think the C board had, you know, a 75% mirror or something on it.
Yeah.
Maybe got one scanner, got some information.
Some of these are pretty interesting as you start flipping through them and you go, wow, there's a couple where I was like, oh, I wasn't expecting that. But
350.
yeah, at the very least, you can start to see there are differences between all these scanners. You know, when you try and normalize them, this is what we see. And maybe it might be hard to read some of those large profiles.
Yeah. Well, some of them don't have a lot.
Some of them don't have a lot of points.
Barrows, yeah. MS. I guess that was the thing too. Some of these are currently on the market. Some of them are no longer on the market, but still, you know, extant out in the world. So.
Yeah, whether it's I mean, these go back to when we did this in 2017. So we had, you know, whatever scanners we had available at that time, we took and we did the comparison. Obviously, as time goes on, scanners cycle out, new scanners come in. Our intent with this is to have more of these, collect more data in the same manner with new scanners as they come out, and keep adding to this collection of data. You know, some people hang on to their scanners quite a while, and you know, they may want to compare it, you know, 5 years from now to whatever is coming out then. They're going to make a purchase or a rental decision. But it just becomes legacy data.
It's just in the intensity value. Yeah, it's not a QA/QC or anything. It's CAD. It's just intensity value. Yeah, I've seen some problems with BLK data.
The idea being that this is the visual to the numbers that the manufacturer present to you, right? So tying into the spec sheet, what does that number actually mean to my project? Well, this is what that number actually means to your project. If you're trying to model piping, then obviously you can see by the cross sections which scanner might be better for you than another.
Resolution, right? How do you measure?
The ranging accuracy or positional accuracy, we didn't get into that with this sort of thing.
Yeah, I say that's not exactly what we were aiming for on this. Is more or less, what are you going to get at this setting? What do common materials that you're going to find on a job site, what do they look like? Can you complete your task with the data at hand at that setting?
You can get the return based on the surface that you're capturing, but is that return accurate in terms of position?
And is it complete for the subject, right? So if you're looking at some flooring and you know that that should be a hard angle for that edge, but instead you get something that's very rounded, then obviously you don't have enough points at that setting to complete that angle.
How thick was the slice that you guys took out?
It's a centimeter.
1 second.
Yeah, so you do get some where there's a couple lines in there on top of each other, but once you get to low, it's pretty much a single line of points. And that was just, we had to pick something. It wasn't possible to pick just one line for everything.
You got a question over there, Joe.
What scanner will give you as a reference? Because you have to compare that to something else as a reference.
This we didn't use any one scanner for the base. We used the room itself to register it. I think I used the Surphaser room. I locked the Surphaser room first, but it could have used any of them because we were using the room as the registration rather than any scan of one board.
So I don't understand then
Well, the colors are not comparing one board to another. The colors are the intensity values captured from the scan. Is that what you're asking?
So you were just comparing the intensity, you getting the intensity values that you were getting from the instrument.
Yes. It's just the intensity values from the instrument.
Thank you. So the instrument that delivered the highest intensity was the best according to your study?
Well, we're not picking best. We're just presenting data. So I think it's important to know that, you know, again, there's a lot to analyze here. All this analysis does right now is it shows you data at a given range with a different scanner on a material board.
They're just showing you, if you use the scanner, this is what you get.
Correct.
But
The analysis doesn't go any deeper.
User, I want to know which one I'm going to go for.
You have to look at
We'll be able to give you the comparison data between the two that you're interested in. We're not holding one scanner as a master to compare everything else to. It's apples to apples. You're looking at two scanners. Here's the data from both of those on this particular board, right? So we're just comparing product A to product B.
Okay. So
It gets us a step closer to being able to understand what these instruments are doing. Obviously, it's going to create a whole bunch more questions, you know, to analyze. This is not a complete analysis of all these scanners. It's the starting point for analysis that currently we haven't been able to do unless someone did this on their own. We haven't been able to do this before. So I suspect as we move forward in time, this analysis will become more sophisticated, and we'll start fielding these questions and go, wow, we really need to figure this next step out. And we want to hear from you guys as to what those next things are that you want to see in the analysis.
So how many operators did the study? One or two, or maybe a combination of both? Because I believe different instruments are going to require maybe one operator only, to two, or none. I'm not sure.
Was that one photo you asked?
No, one operator, one person
operator.
operator.
Oh, one operator. Yeah, it was the same operator at this
Just
lab.
one. Just
yeah.
one. Okay.
And they controlled for the position of the scanner for everyone. They had the tripod set up in the same position and just swapped out the scanner.
Okay.
Yeah, the tripod didn't move. The boards were in their fixed position. All we did was take the head off the tripod and swap it with another head and run another scan with that instrument. We tried to eliminate as most of the variables as we could, you know, just kind of lock these things down.
Yeah, I will say there is a slight variation between 2022 and 2017. So I manually moved the board in a little bit because it didn't get the exact same location. So I moved it 11 centimeters to the right and 2 centimeters forward, and is that the same height? Which Andy wanted.
We're not NIST.
Yeah. Yeah, and that's a high. So we did add some real highs this go around. Your mileage on how much you want to scan in high is going to vary, but there you have it there. Yeah.
Was that original board? Was there some
warp or sorry? Was there any like warp on that original board? Maybe like I'm trying to figure out: am I seeing here reality or am I seeing a warp?
Yeah. So that's the slight. So this was done in 2022. So this was the slight variation in the position. It's not a warped board. The board was tipped back a little bit in this take. So
that's actually pretty good.
Yeah, I debated, if I should, how much to manually move this and how much to just try and, I didn't want to try and register board to board because I thought that would start skewing things. But like I said, the numbers are all accurate in the data itself. This was just a visualization tool.
Is there anything that's standing out to any of you guys in the audience that you'd like to share?
If you can wait for the mic too, we'd appreciate it.
I'm surprised to see the difference between the C10 and the RTC, right? The C10 was a very expensive unit when it came out, was, comparable to the P50 now. But when you look at the data between the RTC and the C10, I mean, it's, night and day. It's so much cleaner, the data that you get from the RTC, which, it looks like a toy. That's what I'm saying, and the advance of technology is just unbelievable. And I know people are still using the C10, so.
Did they stop manufacturing this?
They are not maintaining
Stop
it.
supporting it?
This year's last year for support.
Yeah.
For
I
support?
think this year they're whatever parts are left are there.
Yeah.
So, good luck.
I know a couple people that are hanging on to those for dear life.
We still have one that is used weekly, I would say. It's not out every day.
I did take my Cyrex cord to a Radio Shack to get it repaired.
I was going to say, the edge detection at the different scan levels kind of intrigues me, that you've got a sharp edge there. How well is that going to render, and is our software going to pick up that edge later? The surface noise, like the last image showed, or the one before that, I think.
Was that C10?
Yeah, it's like, wow, the surface noise is just out of control, but it looks standard distributed, I don't know.
Yeah, you just pick the middle.
Yeah, it's always like more points are better, but at what cost? And so I'm kind of curious, it'd be interesting to have a number in the corner on just how many seconds we're put forward to that, and then, but at the raw level of the individual scan, and a lot of our data, we've got hundreds and hundreds of scans, sometimes just an incredible overlap, and the problem is, what does it look like when it's all put together and registered, is there, that kind of thing. But the edges kind of caught my attention.
Yeah, what I'm kind of interested in, I know that there's high resolution, medium, low. It's, I guess the time in minutes for each one. Yeah, because, high setting for, let's say, a Faro versus a high setting for RTC it might be very different.
Yeah.
So, I mean, you could get, 5-minute scan on one, you're like, look at this crisp one, and then the other one could be not as crisp a wave, and there's also on a high, but there's on a 3-minute scan. So maybe adding some time to this would kind of see what
that would be a good metric for.
Yeah, for how long. Yeah.
Right, well that kind of ties into what we were asking earlier about what would you like to see moving forward, and productivity, time from field to finish. How long does it take you to collect the scans in the field, as well as import, process, and get to an export deliverable? So part of that, yeah, I completely agree.
I think as far as the field collection, that could be compared across the board with the local scan. The processing time is going to depend on the workstations you have, everything else.
Right, there's a lot of variables that are involved with.
But I think what he's saying is, high resolution for C10 versus Faro.
Yeah. And I like that.
3 minutes, 5 minutes, whatever it may be.
And from a stopwatch, not what it says on the screen.
That's so true.
Plus, if you're talking Leica, they added 15 seconds on the RTC with the firmware update on the level, right? So when they address that,
you can turn that off.
Yes?
No,
you can turn that off. But it adds 15 seconds that they don't tell you, and that's not been updated in the spec sheet. I mean, 15 seconds realistically is not that long. However,
600 scans.
Over the course of a day, that can kind of start cutting into your overall time.
I think it is important to know how long it takes to do each resolution scan. Like a high resolution on the C10, I forget what that is, probably close to 10 minutes or so, where a high resolution on that RTC is 2 minutes, 42 seconds, plus that 15 seconds. Right. I mean, but then also your file size obviously is larger. I mean, that Leica C10 data, unfortunately the one that we had kicked the bucket, but I mean, you can import a day's worth of field work in 20 minutes. Whereas, you know, obviously if a day's worth of RTC is going to take significantly longer, probably want to do that at the end of the day. But yeah, I think showing how long each resolution scan is to take, because that's important.
Well, I think it's easy to add to this too, so that's a good note. You know, the time of capture and probably, you know, total number of points captured, because I think.
Yeah, it's been a while since I used the Faro. Like I remember I used the
get
Faro
those
on high resolution. It was like 20-something minutes to do like a full scan on full resolution.
Which one was that?
It was like a Faro scanner I used probably 5 or 6 years ago. It was like 25 minutes to do a high resolution scan.
So that's a 1 to 2 at 4 quality, I think, if I remember.
Yeah, right.
In a Condor at the time. With color.
Question, back and forth between the C10 and the RTC.
Yeah.
You mentioned the edge detection earlier. Are there any kind of onboard filtering that goes on with RTC? Because just seeing how much data is missed on that same edge, does it have any kind of onboard filtering, or did you run any kind of filters on these?
The RTC doesn't have an onboard filter for that I know of.
I'm just looking at the data that it's not catching that the C10 did. Yeah, I still don't know what that is.
I will say that what I can speak to is that the import angle filter, when I brought it into Polyworks, I had it set for 83 degrees. So anything beyond 83
But you process them all in the same software?
I process them all in the same
every single one the same. So I'm
Yeah.
curious why the C10 has more data on those inside edges than the RTC does.
Could be the height of the instrument too.
What's that?
Could be the height of the instrument too. There's a significant difference in the height between the HI and the
Yeah, were these all the exact same height as far as the laser data?
Yeah, I mean, that's the one thing, the factor that didn't change at all between the two. Was the height that they shot it at, and he had it set on the same cart, so the height of the object and the height of the scanner were both the same. Oh, I see what you're saying. Yeah, I mean, that's possible, because I was using the room. I wasn't using, you know, the exact center of the mirror for the height. So that's possible. I don't think it would necessarily account for that. You can actually probably see it better up there than I can. Is it all the top angles or all the bottom angles, or?
Yeah, I think my question was, is your bottom of your tri-brac your reference, or is the actual, are you measuring to the HI of the actual sensor, or is it the?
Bottom of the tri-brac. There are some scanners that you can't measure the emission point.
Right.
Some you can. There'll be a dot or a line or something on the side of the unit for your measure up.
So there, in this instance, there is a difference between our sensor and our actual HI. Okay.
Yeah, I would imagine.
Yeah, because the only thing that we can keep as solid all the way through is the height that you're mounting to, right? Where the actual height of the emission of the laser comes from varies from manufacturer to manufacturer. We'd be spending weeks just trying to figure out how to manage that and get them all on the same plane.
Chris, I want to do a test on vibration, how they handle vibration.
The drop sensor just went off. So you can think. This is kind of where I let off. Just kind of slowly rolling through these, but maybe I'll get through and we can always go back again.
Yeah, we may get more sophisticated with this in the coming years. I mean, someone suggested it would be really cool to, you know, pick your data sets you want to compare and then do one of those slide bars, you know, and kind of swipe it back and forth and see what happens. I think there's some really good ideas.
I have you're asking about, you know, what would you like to see in the, you know, next analysis? So I think for me personally, what I think is important, right, is to figure out how the data looks like at various distances from the unit, right? Because like, you know, with the RTC, I cut off the data past 60 meters to reduce the noise and inaccuracy. And there are projects where, you know, I need to choose a unit versus another. I want to know which one should I choose based on how the angle of incidence will affect that result. So it's distance, but also angle of incidence. So yeah, I think it's great to see how each surface reflects light back, but also I think distance and angle of incidence plays a huge role in determining which unit you want to choose.
Yeah, I think that's going to be in the next scanner shootout that Chris is planning.
The large scale scanner shootout would have that taken in account. Using a larger environment where you can kind of test that max usable range of your scanner. Right? Obviously, maybe not a P50 inside. We're not going to get a kilometer away. But for things in the medium range, if you're cutting right now at 60 meters, could you take it to 70, 75? What's that look like, right? Where's that sort of accretion disc where you're just like, no, I'm not going past that, right? That's what we would be aiming to kind of find is a comparison much the same. Instead of taking that slice on a materials board, we can take that slice at a distance and then compare point spacing for scanners and look at it that way.
And I think, Chris, you said you're planning on doing that in an arena of some sort?
The idea is to use something like a basketball or a hockey, some sort of an indoor arena where it's a controlled environment for the most part. The structure of the ceiling is not going to change. The seats are not going to change that much. Right? The only thing that would really be subject to change would be the floor based on what kind of events are happening. But we would try to manage that as best as possible within that environment.
Sylvie, would a venue like that, you think, be sufficient for what you're looking for?
So now we're going to get into whether or not you have these things available here. So this is, on all of the data, this is the convention that I used. The naming convention. Yeah, the naming convention. So what's been exported is these two formats. So just straight up ASCII, with text file for each individual board. And then I've got them all in recap as well. And that's for what we just kind of went through with B, and then also for the first go round of C and B with the new scans added.
So
screenshot.
Yeah, just to follow that up real quick, what our intent is to make this data available to you guys. We're in the process of saving it out. We're going to put it on the USIBD store. You guys, it will be available for purchase. If you're a USIBD member, you'll get your USIBD discount. So, members, non-members alike can access this data. It's in, you said, 2 formats, correct? For each data set. So if you want to do a comparison, you'll download, pick 2 data sets you want to compare. You'll download each. You'll get, 2 file types within each data set to compare. Is that what we're doing?
I'm not sure how you're going to slice that.
Okay. I think that's what we were talking about. We're still working it out.
That's the idea, John.
Yeah. So anyway, that's coming soon. The data's there. We just got to package it up and get it into the store so you guys can have access to it. Then you can start to do your own analysis on it with what we've collected. We'll do many more analyses in the future, many more tests with different venues, but your feedback is going to be real important to us.
Yeah. Help us to help you, right? Jerry McGuire, help me help you.
What's that, Joe?
That is the that is the teaser.
Oh, that's a teaser. Well, what is it?
So that's the Nevis in that same environment. So we started messing with it and basically just walked a circle around the position for a little while to get comparable data as much as you can. We've been using apples to apples, but I think at this point it's apples to squirrels, or I don't know what you call it.
Andy had a VLX.
Again, every tool has a purpose, but.
Andy had a VLX in his shop. We're like, hey, that'd be fun. What's that going to do? How do we compare a mobile unit to some, terrestrial? I don't know.
What's a scan? What's a scan with a mobile unit?
Yeah, it was just more for fun right now.
What does the resolution mean? I want to send them our Matterport just to play around with.
Yeah. I think in the future...
People keep calling them scans, so we should test them out.
Yeah, you want to borrow my iPhone?
Yeah, I got to do that too. I just got my 13. We'll do that too.
Anyway, maybe we do a mobile scanner shootout at some point once we figure out how to do that.
Do you want to talk to this?
All right, so again, we're on analog here, so I guess, yeah. Would you be interested in purchasing a USIBD test set of data? How many people actually would be interested? We got at least a few people, yeah. Okay, that's good to know. We're like, we think it's valuable.
Yeah, what are we talking on price on this?
How much you want to spend?
30 grand.
30 grand. Going once? Do I hear going twice? Is that one data set or the whole thing? Per scan, yeah.
Do you have some of the comparison of the available on the site?
We've got some on there now. We haven't really discussed, I mean.
Why don't you guys show them?
Just you mean the screenshots of them?
Yeah, just kind of.
I forget what we have on there now. We haven't updated it.
I'm dropping the site there. They all exist.
Yeah, I think there's 4 on the site right now, if I'm not, I don't remember which models. But go to the USIBD website, go to the committee, laser scanning committee page, and you'll see them there. Whatever, I don't remember which ones. Right, let's see. Oh yeah, there you go, get test data. I don't think it's published yet, but it's gonna be shortly. That QR code will take you to where it's going to be posted. Is that right, Eric? We don't have them up there yet, or do we?
That's correct.
Okay, it's in process.
We just went through a whole new revamp with the website, so it's newly branded and all that kind of good stuff. So we're still working through some of the details. So we'll get that up pretty soon.
Okay. Anyone need this? Can I advance? Yep. Okay. All right. Do you own or rent your own scanning equipment? How many people rent? Just a couple. Most of you guys own, I presume? Yeah? Okay. Interesting. For those that don't rent, why don't you rent? You do both?
Yeah, just it's in the office, right? Like I can get people to grab that and go rather than having to deal with renting, right?
The convenience, no shipping cost. Yeah. Okay.
I know there's hands, the equipment's in every day rather than the rental people throwing stuff around.
Yeah. All right, let's see.
So, by the way, now some of the hardware vendors are offering long-term lease versions. So rather than renting it and having to send it back right away, you can agree to have it for a certain period of time, a couple of years, 3-4 years, whatever, and have it in your possession, sort of like leasing a car, right? So you use it, it sort of acts as your own. You have it in the office, you have the convenience of having it at your disposal, but you don't have to, bring it back right away kind of thing. They usually package maintenance and different things, the maintenance of it, calibrations, checks and things like that. So very similar to like leasing a car. So just heads up on that. There's kind of a third. I don't think there's a limit. I think you can use it as much as you want. So
interesting. Bad news for Andy. Okay, and then just you're going to have to. I don't know how you do the smiley face or not. Did you guys enjoy this presentation?
Yes.
Yeah.
Great.
Would you like to see an update in the future?
Yeah.
Yeah. Cool. All right. Well, I'm going to thank our guys here. All right. Oh, and just a shameless plug for the laser scanning subcommittee. If you guys are interested in this stuff and want to get involved, we're looking for more people to participate with us on the subcommittee. So, and there's probably perks and benefits to that as far as access to data, I would imagine. But we encourage you to get involved if that's something you're interested in. Thank you, guys.
Hey, great job. Thank you.